started with the birth of electrical discharge machining and the rise of technologies and miniaturization. We responded to new industrial challenges. We innovated with a disruptive laser technology, and femtosecond laser opened new horizons. We expanded our portfolio with microlution. We multiplied by 5 the productivity of our laser solutions. Now, we machine the most challenging materials and reach a superior level of dynamics. At GF Machining Solutions, innovation is key.
Yeah, thank you. This is Juan Manuel Gomez. He is Manuel Gomez. He is not for the first time presenting here in Berlin. I think it is your second presentation, and the first time we had a virtual tour, of course, with you. Now you are live on stage and you have all the friends in front of you. Yep. Welcome in Berlin, and the floor is yours.
Thanks a lot, Peter. Thanks a lot. Thanks a lot for the opportunity of being here. It's a pleasure. I will talk a little bit about what's the state of the art of laser machining, the mint and metal industry, and I will give you a few details on a great tool that unlocks the third dimension, which is the 5-axis laser machining. So you've seen a little bit in the teaser, GF Machining Solutions. We are a Swiss machine manufacturer. We provide high-speed milling machines, EDM machines, and laser. As for the laser, we are in charge of engineering the machines, but also the CAM system. This gives us really the freedom to innovate at our pace, and as well strike a good balance in keeping things simple and user-friendly. We are leading providers of 5-axis machining centers for laser in different industries, but essentially the types of applications we do are just 2 of them. First is laser texturing, where we applied normally aesthetic textures of any 3D part. It can be even a part that is several meters long. It can be a small part for the watch industry, for instance. And what we are really seeing, thanks to the advent of femtosecond laser machining, that there is a lot of interest in laser micromachining, which you can assimilate to laser milling. We remove material, sometimes in applications requiring really high precision within microns. And of course, we have also, as the last picture shows, laser cutting and laser drilling applications. Now, in the mint and metal industry, one just needs to come here to Berlin every January and see that just walking around the stands, we see crazier and crazier things. We see unconventional machining or manufacturing methods everywhere with 3D printed coins, composite coins, plastic injection. We see unique designs in 3D. I mean, it's just fantastic. This shows that innovation is really driving this world. And also for the laser, it's happening. In fact, regarding laser, we've seen lately the following trends coming up. So customers are getting more interested in customizing, really fine-tuning the finishing effects, the traditional ones, but also new ones like the brushing or the polishing. Then we have also requests to do deeper designs, deep dye engravings. The metals are getting bigger, they are having higher relief, so this is becoming commonplace. Now we are doing projects up to 10 millimeters in depth, with, of course, finishing applied to it. And, of course, requests of PVD decoating, which this all shows how flexible the laser is as a tool for a mint and metal shop. So let's just review a little bit every single of these 3 points, starting with the finishing. This is an example that we've done a while ago, where we have a lot of different finishing cycles. We have a frosting. We have 10 different gloss levels on the wings of the butterfly, and we have a scintillating glow on the diamond. And all this is possible by mastering the laser parameters, and our systems allow easily to do that. Moving to high relief die laser engraving with laser. This is a nice example as well. It's 3 millimeters deep. It's the shape from this hummingbird. And we also perform some frosting and glossy finishes at the end. And the most interesting part here is that we have done it on a dome that has a height of 3 millimeters. We use a quite funky machining strategy that follows the shape of the dome progressively to make an engraving that looks really fantastic and is right to size and actual to size everywhere on the circumference of the die. Here in the video you can see a finishing cycle where we are completely following the shape of the engraving. Now this technique is great, but it has some limitations, as I will show later. Let's imagine that now we have to perform a finishing on this part. This is a very high relief part, and in fact, if we apply the same procedure, so essentially what we are is sweeping the surface all over the height and then just moving the beam, what we are actually doing is this, schematically. This is our beam, and the beam is doing like that, okay? So it goes up and down, following the surface and progressing over the part. But there's an actual problem to that, and it's that when you get to high relief ratios like this is what is going to happen. If you compare the beam at the center and the beam at the side, when you project the beam on the surface, you would like to have a circular spot, very small. But actually at the side, what you get is a projection of the spot, which is an ellipse. And that's a problem. In laser, we always want to be perpendicular to the surface that we are machining. When you get an ellipse, you are having the same energy, but over a bigger spot. So your energy density is going down. Besides that, if you have lower energy density, you have lower material removal rate. So what you can expect is that you get different results on the blue spot and on the red spot. And last but not least, you will lose even more energy due to reflection. Most of the energy will be reflected and will not be used to ablate the material. So how do you solve this? I mean, sometimes you can just live with it, but for instance, if you take this part, it's the same as before, but now we are doing a brushing. The brushing is extremely sensitive to this phenomena that we just described. So a solution is to use a five-axis laser machining strategy. How does it work? Our software takes the surface and will patch the surface. It will divide it in tiles, if you want to call it like that. And the programming of the part will be done in a way that for each tile, the machine will position the part and the beam so that the beam incides in the most perpendicular way to the patch. So one patch is one machine position. And this is programmed automatically. Our software generates the patches. You can also manage the interface between the tiles so that you don't see anything. What we are actually doing is this. If we go up to our previous design, the laser is doing one patch, then we will move to another one, we will move the part with respect to the laser, and then another one, and another one, little by little. And every slice that you do, the patches are redistributed to keep it random and to have a really nice uniform aspect at the end. So you see there's no visible patch boundaries, and it looks great. And it's also very efficient, as I will show you with an example. If we take the same shape now, I took this example where we put this shape, we coat it with a black coating, and we try to uniformly decoat the part using five-axis machining strategies. So this is how it works. We program it on the machine. Now we are referencing the part, and we are ready to shoot. So what is going on is that the part is set up in a way that the laser is every time, as I said, perpendicular to each patch, and we go little by little, removing everything all the coating on the part. This is real speed machining. And this is a really interesting technique. For instance, when you're removing a quite thin coating, like PVD coating, diamond-like coating, on a part that is not flat. If it's not flat, as I said before, in the places where you have high relief, you will not be able to remove effectively the coating, or if you want to do it, you will touch then the metal on the flat parts. So that's the correct technique to remove a coating on a part that is really far from being flat. So it's finishing and it's over. So that was real-time decoating. We must not, of course, we can go further. We must not limit ourselves to decoating. We can also do engraving on 3D. So if you take the edge color molds for the coins or for the medals, you can perform the lettering on relief. You can engrave the lettering. And you can also do it continuously. And for that, I present you with this example where we started from a cylinder and we created a notch all around and also a thread with an amazing quality. So I showed you more or less what is the interest of 5-axis laser machining. Last year, we presented a new machine. It's called the Laser S500U. It's our most precise machine. It's dedicated to micro-machining in electronic components, stamping components, etc. And of course, this is a big moment for us, and we wanted to celebrate in the same way that is celebrated by you sometimes, which is creating a commemorative medal, let's say. But because our machine is quite special, we created a very special medal. It's called the iconic part. And it looks like this. It's unconventional, of course. We have a cylinder or kind of a parabolic shape and extruded in 3D that is huge. It's 200 millimeters high, 72 millimeters in diameter. And we created two textures, one that is kind of a natural texture with colors, and another one that is more technical, which reflects our both backgrounds, micro-machining and artistic texturing. And the part looks like this, compared to a PET bottle. Just let me share a quick video on how we did this part. We started from additive manufacturing. We cut the parts, and then we moved it on into the milling machine to create a right polished surface that we need for the laser. So here is the final result. And then, obviously, it's time for the laser. But before, we need to program. So the first step for the lasering is to go back to our desk, take our part, and start creating the textures and the engravings. So here is the toolpath that is created for the bionic or natural part, let's say, and the technical side comes afterwards. Here it comes, and as you see, every color is a patch. So every color represents a position in the machine. And this is programmed, as I said, automatically. Of course, you have some wiggle room, but you don't need to know. Then it's time to put the part on the machine, click start, and then cross your fingers. Nah, I'm just kidding. You will have a good result at the end. This is the result we got. The part looks fantastic. You can come to see it in our booth. Everything is, all textures that you see are done in a single setup with a single machine, in a single programming step. And for me, I mean, what I love the most is the micro-machining part, which is fantastic. You see no patches, even in large areas. So it's really a feat, what we accomplished here. To conclude my contribution today, I just wanted to leave you with some remarks. We are laser machine providers. We also develop our own CAM, and we are at the forefront of developing new strategies. And as well with our unique 5-axis laser strategies, you will be able to unlock this third dimension and perform any operation that you do today on the flat, on any 3D surface. So that it's a gateway, of course, for innovation. I thank you a lot for your attention. Thanks.